Hey guys, welcome to my channel. In this video I am going to discuss with you the breadth first search graph traversal algorithm. Now for the breadth first search graph traversal algorithm we need the data structure called queue. As you know, queue is a data structure in which we can enqueue or add an element from the bottom, and we need to dequeue or remove that element from the top. Okay, so we need that data structure here in order to maintain the record of the visited nodes. So let's start. We need the queue and the output. Okay, so what we will do here, we will take a node, mark it as our currently used node, and we will check for its adjacent nodes. Now the adjacent nodes that we will get, we will enqueue them to the queue, right? And the node that we are currently working with, we will write it in the output section. Okay, now as we update our currently working node, we will pop it from the queue and we will add it to the output. Okay, so let's see how it works. Now this is the graph. This is a sample graph and we need to traverse it using the BFS algorithm. So let's start. Step 1 is starting with the node A. We are adding it to the output and marking it as a currently working node. Okay. Now let's check for its adjacency. We can see we have two nodes, B and C. Okay. So let's add them. So B and C, right? Now what we will do, since C is at the top, we will update our currently working node to C, right? And we will pop it out. So now what it becomes is B at the top, output is AC, right? Now let's check adjacency for C. We have B and D and also A, but we can see A has already been visited and B is already there in the queue. So we are left with D. So what we will do is we will enqueue D here, right? Now next step will be popping out B. So let's pop out B, and what we will do is we will add B to the output. So ACB, right? And here we have D as the topmost element. Okay, and B is our currently working node. Now if we check for adjacency of B, we will see that we have A, C and D as the adjacent nodes of B, but A and C have already been visited and D is already there in the queue, so we can't write any one of them. So what we will do is we will update our currently working node to D and mark it as visited and just pop it out from here. So what will be our status? Our output will be A, C, B, D. Now let's check adjacency for D, and we can see that we have C, B, E and F. Since B and C are already visited, we have left with E and F. So we will just enqueue them. So E and F. Now since E is at the top of the queue, we will pop it out, or rather dequeue it, and update our currently working node to E, and here we will update our output, that is A, C, B, D and E. So we are left with F. Now let's check adjacency for E, which we have just popped dequeued. So we have F and G. Since F is already there in the queue, we can't write it again. We are going with G. So G. Now we have F at the top of the queue, so we will dequeue it. So F is being dequeued and we have G left with us. So output is A, C, B, D, E, F. And we are marking F as the currently working node. Now if we check for adjacency of F, we can see that no node is left unvisited. So we have no choice other than dequeuing G here. So what we get is an empty queue again, with which we started, and the output as A, C, B, D, E, F, G, and we have this G finally visited. This is the currently working node, and we can see that there is no more unvisited adjacent nodes left. So this is our result of the breadth first search using the data structure queue. So this was all for this video. Thank you guys for watching this video. Stay tuned to my channel for my upcoming videos. Do subscribe to my channel if you haven't yet, and press the bell notification icon to get notified whenever I upload any video in future. Thank you.